Hello. In this video, we are going to go over a statics problem where you're given some distances and 2 points in 3 space, and it is asking us to express the force as a Cartesian vector. So we're just given a magnitude, and just as a reminder, if I have some arbitrary vector A Cartesian vector is written like this. So our answer needs to be expressed in that form right there. So the first thing that we want to do is find the coordinates of A and B. So for point A, we have, you can look at the x-axis and see that it's 2 meters on the x-axis. We have 2. It is 0 on the y-axis, and it's 2 meters on the z-axis. And then for point B, we can see that it's 3 meters on the x-axis. It is, It is 4 meters on the x-axis. It is 3 meters on the y-axis, and from here we can see that it's going down. So it is 4 meters on the z-axis. So now that we found our coordinates, this right here is just a magnitude. So if we are going to express it as a force, we need it to have a magnitude and a direction, which requires us to find the unit vector. And to find the unit vector, first we need to find the position vector. So we need to find the vector from A to B, which is notated like this. And the way that we find the position vector AB is we need to do B minus A, right, from here to here. And we need to do, in other words, like the head of the vector minus the tail of it. So B is 4, 3. Oops, this is supposed to be negative. Make sure you have that correct. -4 minus A, which is 2, 0, 2. And so I'm just going to subtract each component. So we'll have 4 minus 2, which is going to be 2i. 3 minus 0 would be positive 3j. -4 minus 2 is going to be negative 6k. And so we need to find a unit vector for AB. And you need to remember this formula. A position vector equals the magnitude of that position vector times the unit vector. So if we are trying to find U, we can divide the position vector by its magnitude, and that will give us U. So we need to find the magnitude of RAB, which is going to be the square root of all your components squared. Which ends up being 49, square root of 49, and that is 7. So now to get u, AB, we're going to have the position vector, which is 2i plus 3j minus 6k all over 7. And you're just going to take each of the components and divide by the magnitude. And I like to keep them as fractions because it's more accurate that way. Then you don't have to round with decimal numbers. So I'm going to write this as 2 over 7i plus 3 over 7j minus 6 over 7k. So now we have our unit vector from A to B. And if you recall this formula, a force vector equals the magnitude of the force vector times a unit vector. So this is what we're trying to find. That's this right here. And we were given the magnitude of F. So for us to find the Cartesian vector, we're going to have the magnitude, which is 630 newtons, times the unit vector, which we just found. And so I'm going to multiply 630 times each component, and that will give me 180i plus 270j, 630 times negative 6 over 7, and that gives me negative 540k. And that's all in newtons. Now, this is the final answer, but the question says to enter the x, y, and z components of the force. So we can just write it like this. Fx is 180 newtons. Fy is 270 newtons. And Fz is negative 540 newtons. Just to pay attention to the question, it just wants you to write it a certain way. This is how the question wants you to write it. And that's it. That's the answer.